Hello, my name is Paweł Charzyński. We'll talk about optimalization of VFXs, how I did VFXs in Frostpunk 2. So let's go. Something about me. I'm working at 11-bit studios, of course. I worked on several AAA projects. Other passions are DJing, producing music, board games, of course. Like my adventure with VFX started in 2019. I was producing some visual effects for film and TV, but I quickly switched to GameDev because it's my passion. It started with Call of Duty, and I've been doing this since. So we'll talk about debugging Niagara tools, what is optimalization in general, about Niagara ribbons and when to use them, something about shader complexity. Oh, sorry, my ear is. And yeah, Niagara emission points, it was the main system used in Frostpunk 2, basically. It gives us like really big opportunities to spawn a lot of systems in our game. Like, if you don't know, Frostpunk 2 is a real-time strategy. We're building the city, so there's a lot of buildings, a lot of smokes. There's snow everywhere around the city, so we had to do some stuff to make it look as good as it is. We will talk about Niagara effect types, so culling, frustum culling, distance culling, stuff like that. So, key concept of optimalization. The main case about optimalization is less is better. So everything costs, spawning costs, when you're producing the translucent sprites or additive sprites, and they're on top of each other, it also like, it makes the shader complexity really bad. So we have to, as a VFX artist, we have to take into account what we can do, not only the visual concept of, I don't know, big fancy explosion at the whole screen. Yeah, right, but we have to spawn it, and as well, you have to remember that, yeah, you're using your computer, your PC, and it's like great PC. It have a really big amount of RAM, some, I don't know, 2 GPUs connected with each other inside, but gamers don't really have that good equipment as you, so you have to take into account that they won't be able to see like as good quality as you do. So you have to prepare your VFXs for a medium, low, and of course high and cinematic quality. About VFXs in total, you have to remember that those are add-ons, basically, to the key game. Like, there's a lot of more important stuff that you're rendering. So in Frostpunk 2, we had to prepare the game so we can display the whole city inside. So there's a lot of vertices. And on top of it, we have to add some smokes, some wind effects or something like that. There's UI as well. And the most important stuff is to present the player, the things that he have to see, basically. So your budget is limited, always. So you have to just manage to do some things so it will be so the more memory will be for important stuff. And VFXs are mostly visual things. So for debugging, I used the Niagara tools. Of course, there's a FX outliner, debug HUD, and shader complexity. Some debug views are really helpful as well. But the main, like the application stuff, how to manage those things, is the Niagara debug tools. You can see there, is the emitter is on CPU, on GPU, is there some memory leaks, or I call it zombie emitters. So it's then basically the emitter that should cool, or after the further distance, it should just stop emitting particles, but it's for some reason still active. and your setting, you can easily like see what's happening when you open that debug HUD. There's a lot of things inside there. So there's 5 basic categories. So Niagara debug HUD is the most important one. You can set the visualize of bounding boxes there. You can see all the systems inside the game with their pivot points, bounding boxes. You can see how many particles are spawned at the same time. You can filter the systems. You can filter the emitters there. You can also show some particle attributes without changing it with material or something like that. And it all happens at the real time. So when you open the game, when you play it, you can easily check what's happening under the HUD, basically. That's the visualization of bounding boxes. Bounding boxes are basically the things. Another way. Sorry. You can put emitter into the CPU or GPU system. So GPU systems are connected with the bounding boxes. When player see the bounding box that you can put into the dynamic, fixed, or programmable mode, then the whole system will play. So you have to set it up in a proper, not too big, of course, bounding box. So it will optimize properly and cool the given systems. In FX Outliner, that's a lot of information there, stuff like that. You can check the state of the given emitter. Is it active or is it deactivated? Is it in CPU or GPU? You can check if there's some memory leaks there. Basically, there's a few filters there, and you switch between them. Like you're going to the debug mode to see what's active, what's not active, and then you can switch to performance to see what's really happening, what's the payload of the whole spawned GPU. And there's an individual takes and all the systems that are spawned inside the current level right now. So yeah, really useful. I use it a lot. And we have the 3 others. It's performance, when you can apply the predefined some predefined tests. You are basically catching the 60 frames, for example, during the playthrough, and then you can check how the emitter scales with much more CPU upload and stuff like that. So Session Browser is mostly for multiplayer games because when you're making a multiplayer game, not every VFX should be linked with each other with a local host and a multiplayer host. Sometimes you want to only spawn some systems locally, and the other players shouldn't see it, basically. So it's really useful to see what's happening when you're making some co-op game, for example, and what's happening on the other side of the client. We have a debug spawn as well, and that's basically a spawner. I remember in Unreal 4, I used to make blueprints that was just on event tick, and every, I don't know, 1 or 2 seconds, just spawned something in a place. So thanks to Epic Games, we don't have to make your own blueprints. It's already inside the Niagara. You can change the tick size. You can spawn as many systems as you want. To see how they behave in much more quantity, basically. Because when you optimizing your VFX, you shouldn't look at it like an individual. You have to spawn it like 100 times, 1,000 times even, to see if it's viable, basically, for this kind of game. In Frostpunk, we have a lot of VFXs, and We also have some issues with ribbons, of course. Like, what is ribbon? Like, in Niagara, basically, we can spawn sprites, ribbons, and meshes. Ribbons are basically 10 different particles that are connected with a ribbon link order, and it gives the information for a GPU to render them all together. We are connecting them with ribbon ID as well, and in Unreal 5, basically, right now it's fixed in 5.5, but previously it was just messing around everything. As you can see, sometimes ribbon ID just doesn't work because reasons, I guess. So it was really awful. As you can see, we had that glitches, artifacts all over the place. And we had to do something about it, basically. But we didn't really know why it's happening. We didn't know why it's happening. And we imported the code from 5.5 inside our version of engine. And it kind of worked, but you have to disable tessellation. Tessellation is like improving the amount of vertices in a given ribbon. When it's doing the curve or something like that, so it won't be edgy, jaggy, or something like that, we're just increasing the vertices amount. But when you're spawning a lot of ribbons around the city, after every like people that are walking on the streets, behind them there was a ribbon, so there was a lot of ribbons. So we couldn't do tessellation. It should be as optimal as it could be. So we thought, well, ribbons are really expensive, basically, because as I said, it's 10 particles behind one particle and spawning costs. The more emitters you have, like the worse optimization will be. So you don't really have to use ribbons all the time. Sometimes you can just switch it up to the sprite. There's a wireframe here of a ribbon. As you can see, it kind of it's just a straight line. So why do I need so many vertices there? I can, if I know the trajectory, and if I know the velocity, I pre-calculate all the distance that it goes through, I can change it to the sprite, disable the tessellation, change the pivot point, and it will look fine. And it will also reduce the amount of emitters, because when we're producing the ribbon renderer, there's an emitter for a source that gives information to the ribbon renderer where it should be. Another emitter is ribbons, and the third one can be, I don't know, muzzle flash or some impact position, something like that. We have 3 emitters, basically, for it. We can put it inside one emitter, and there's comparison. Like you can't really see the difference, and you're reducing the amount of particles like 3-4 times. You're reducing the emitter from 3 emitters to 1 emitter. Basically, what you have to do is pre-calculate the trajectory, put a lifetime there, change the values of lifetime for different renderers, so it will use different values. Then you can put, so the trajectory will travel from 0 to 0.8, for example, and you leave the 0.2 for impact or explosion or something like that. And it also, it's really like good for optimizing stuff. Right now you can do it on GPU, so yeah. And the next thing is shader complexity. So white, bad, green, good. So how to reduce the shader complexity? The more amount of translucent sprites that you have on the screen, it can stutter the GPU. You have a lot of things at screen at once. So you have the static meshes then you put the translucent sprite on top of it, on top of them, and you then have to see like what's going on in the shader complexity. You have to also remember what quad overdue, of course, and so to make proper translucent sprites, you have to use cutouts. As you can see on the previous one, like cutouts are basically reducing the amount of non-used translucent sprite, and you predefine it with a texture. I used to, when I'm making my smoke textures or something like that, I'm exporting a pre-multiplied alpha, so it's really, so it's just information from 0 to 1. It doesn't have any grayscale or something like that. It's, so it won't be as edgy as it is. And to properly put the cutouts inside the Niagara renderer, you have to put it in a sub-UV, and then when it cuts through the texture, basically, it have this sub-image index that's driven that animation of cutouts. So it's another variable that you can change because you have to basically use it every time when you're making some small smokes, some really quick flip books, but there's an issue when you're making a really big explosion, like, I don't know, for a whole screen. Then these flip books can be really big. You're applying the motion vectors there, so it will be so the movement of the animation will be smooth as it can be, and the lifetime is like 10, 12 seconds, something like that. So to use motion vectors, you can't really use this type of texture. You have to go to the engine and put the animation inside the material itself. So you're not driving it with sub-UV blending. You're driving it with another material variable inside. So if you're using motion vectors, suddenly your flip book changed from to a whole. The whole sprite is filled with smoke emitters. So how can I really apply the motion vectors there? The solution is kind of easy, to be honest. You just have to multiply the UVs. So the animation itself is put it inside every little storage that sub-UV inside the diagram did, and then goes with that pre-multiplied alpha from a source texture. It's a really good hack. You just put the flipbook animation variable inside the renderer bindings, and you put the same value to drive the animation of motion vectors as well. So it's connected, and cutouts doesn't cut used pixels. It only goes with unused one. So about the Niagara emission points. Basically, the less systems you have on level, the better. So in Frostpunk 2, we have, you can place the district extraction, for example. There's a lot of smokes from coal, from factories, but there's also smoke coming from housing districts, for example, just because there's chimneys there and we want to make them feel more alive. So Marcin Olszewski, that have talk tomorrow, I recommend it, of course, give us solution of Niagara emission points. What is it? It's basically we iterate the position values, lifetime values, at some different levels. So we spawning, instead of spawning Niagara system on a chimney itself, because remember that all chimneys have the same calculations, basically. So they should look kind of the same, Of course, you have some randomized values inside, material or something like that, but the calculation itself are staying the same, so it will behave the same way. So what we did, we spawned points on the chimneys, only points that stored the position values, and then we iterated through the Niagara system. We had one big blueprint that was spawning our Niagaras. We put some emission points, as you can see, in chimneys on those squares. So the points on squares spawn people, for example. Chimneys spawn smoke. There's some actions that player can do. So some protests as well are spawned through emission points. So it just iterates the values between the whole district. So, the issue with this thing is the bounding boxes. So the bounding boxes in our game are huge, because if we put it in some small values there, it will just cool every smoke if you're not seeing the middle of the blueprint, because all cooling, Frostpunk culling, distance culling, and stuff like that from Niagara effect type is calculated from a system simulation position, so from local point of a system. And our city is really, really big, so we applied the really big bounding boxes and put some crazy values there. Something distance culling is like 50,000, something like that. So it basically calls when a player is moving to another city, colony, or going to different view mode. So he's looking at the Frostland, so it's more further away. Then we cool the systems itself. We have, in our game, there's a lot of different systems that are working on it. We have also people on the streets, and those are also the emission points. So if you put Frostpunk 2 in debug mode, there's a lot of things everywhere, basically. And this system is working all the time. It have to work all the time. So when new variables, new position is given, then we're increasing the spawn as well, because every point should spawn the same amount of particles. So we're increasing the amount of the spawn itself, and then we're adding to the vector array the position, and it just works. So yeah, but in 5.5 Unreal, there's a new thing called Niagara Data Channel, and that's basically the same system that we did in Frostpunk. It iterates through this thing, so you don't have to ask your tech-hard guy to do some stuff with your project. You can use the already given Niagara Data Channel. I recommend using this in islands mode because it's more optimal. It basically spawns the Niagara system inside some islands, and we'll call it islands, and you can predefine the bounding box that should spawn the new systems inside there, and you can have the quantity of systems as well there. So yeah, I really recommend to give it a try. It's a good way to optimize quickly your game. And they also added a new thing called lightweighted emitter. And lightweighted emitters are the most basic, as you can see. Like there's a fountain here emitter. I just put it into lightweight. It's really limited things. You can't put scratch pads there, so there's no you can't add your code to the shader itself, but for some environmental things, some looping particles that are basically infinitely living, stuff like that, it's really great. It's really light. It's almost free for a GPU, basically, but it comes with the thing that it's really, really limited. There's like 10 or 15 some fish modules there that you can use, but for some FXs, it's fine enough. You can't also modify the material attributes, but yeah, that's life. But it looks like really similar. There was some spawning bugs inside the 5.4, but right now it works just fine. So I really recommend to give it a try in your project. And Niagara effect types, sorry. So, to properly call Niagaras, you have to put them inside Niagara effects type. And this thing decides when to cool the Niagara, basically. You can put the update frequency. I recommend to use a lot of different values settings here. So you have the burst impact particles, for example, system. You don't have to check it every tick. You can check if it should be visible only on spawn. So it won't add additional things to calculate there. There's four different update frequencies. There's a spawn only, low, high, and every tick. I really used only low because it checks for every 1 second, and that's fine. Like really, that's enough basically. Yeah, and you can put the signifiance handler there and call reaction. So you can choose, do you want to kill the system or you just want to deactivate it and it shouldn't be killed. Maybe it should stay inside the level and just wait for some reaction from a player. Or maybe we don't really need it after the visualization. Then we can just kill it and throw it out from the memory. And we can drive it through the edge or a distance from a camera player. So it checks distance or the edge. It gives the proper. It decides which system is more important based on distance or age. And that thing also allows us to disable some VFXs on lower settings. So if player, for example, have low effects settings inside the Unreal, inside the game, then we can just deactivate the whole system. If we have some fluid simulation, some fire simulation and stuff like that, I don't think some Mac from 2015 should running those things. Because, as I said at the beginning, visual effects are like basically the add-ons to the things that player should be reacting with and stuff like that. And we have the visibility culling and budget scaling. So visibility culling is basically the Frostpunk culling. If player doesn't see the effect, it shouldn't be spawned, it shouldn't be calculated. The issue with this is like when a player moves really fast, he can see the system that starts to spawn, not in the middle of things, so it just breaks the illusion that it was always there. What we can do is put some pre-ticks inside the system so it won't start from 0 position, but from a second or third second from the emitter, but it also increases the tick time. So yeah, use it carefully, basically. Oh, you have to yeah, and all of those things from Niagara effect types, you can go to the scratch mode, scratch path inside the Niagara and put some custom code there and use those values as well. So distance fraction, for example, is set inside Niagara effect type, and if you change the Niagara effect type inside the system itself, then this fraction will change a little bit. So I used to put some custom spawning scales or something like that. It's really useful. LOD distance, time since rendered, and the most important one is quality level. Just remember that those values are read-only. You can't change them. No, you can change them, but you shouldn't change them inside the scratchpad because it can get really messy and you have no idea what's happening, basically. And inside the Niagara emitter itself, inside the renderer, we have a scalability as well. So we have additional optimization paths only for some sprite renderers or ribbon or something like that. The most useful thing to use it is, for example, we have smoke, translucent smoke. We want this smoke to be kind of visible, so it will have some movement. It will represent the thing that we want to add, but on low specs there shouldn't be as much translucency and stuff like that. So what we can do is on medium, high cinematic quality we can put the translucent sprite, and inside the low quality we can just change the material instance from translucent to masked. And yeah, it will look like worse, but yeah, at least it's there, you know. So that's a really fun hack to go for low quality settings there. So inside the Frostpunk, in total, that's the way of the emitter. So first thing first, it checks if scalability system allows to be activated. So at first, it checks if, okay, I'm on low settings, maybe I shouldn't even bother with this system. Then it puts through the frustum culling. So if the player see the emitter, then checks for a distance culling. Okay, if the emitter is in a good distance from a player, and then it checks for max possible instances. Max possible instances is really helpful if you have some memory leaks or you don't want to spawn a lot of systems from a muzzle flash, from a bullet trail or something like that. Then after it passes the Niagara effect type logic, then it goes inside the Niagara itself. And then it checks for emitter scalability settings, so that thing at the really bottom. Then it checks for active emission points. So if there's some active emission points inside our system, then I can spawn some particles. We have also city mask logic. There are some masks that helps us with snow melting, for example, or gives us information about additional things that's happening inside the city. So there's a protest inside one district, so we want to paint, I don't know, particles for red or something like that. And after that city mask logic, there's additional Niagara logic. There's every system have different logic because it represents different stuff. And yeah, and that's it, basically. So I learned a lot during the development of Frostpunk, but what I can recommend you is to customize your Niagaras, so you don't have to type every time randomizer float, like something like that. You can just put Niagara dynamic input scripts, put it in Paweł category. Of course, it has to be Paweł category. And then you have listed all your custom modules there. And you can do it with dynamic inputs. You can do it with some sprites, module scripts, and stuff like that. I highly recommend it. It's improved my workflow like 2 times or 3 times because when you're making the new system, you use the same logic you're in a different system, so it's just really useful. You can access the really big amount of variables inside the material parameters of a Niagara renderer. So you can put some panner. For example, you have texture with a panner, but you want to address this panner so it will be in world position and it was calculated inside the Niagara. You can put those values, store it inside the material attributes, and apply it to the material instance that you're using. So you don't really need that much of that many material instances in your project because you can modify them inside the Niagara itself. If you want to change one variable or you want to animate the one variable, it's really helpful as well. But one thing that you have to remember is that it changed the attributes in a material for every particle. So if you apply it to the one emitter material bindings, it will apply to every particle. If you want to address so the particles will behave kind of different, then you have to put it inside the dynamic parameters. There's a lot of different things that you can use. Particle radius, random value. I use random value in almost every material. It just takes some random 0 to 1 value, and I added to the, I offsetted the textures with it. So every sprite have kind of different texture placement. And just remember that, okay, it reads those values, those, I don't know, particle lifetime, for example, but you don't really have to use it as particle lifetime. Niagara gives us so many possibilities that we can change every binding that we want. So feel free to explore, see some, do some crazy stuff with it. It's real fun. And there's also the thing that's called Niagara validation rule set. That's the new one in 5.4. It was, and it helps you with workflow. Like you have a lot of Niagara systems inside your game. We have around, I don't know, 100, 200. And you can put some validation rule set, so it screams basically at you in a message like, hey, well, Paweł, what's happening? Why you didn't add a bounding box there? Or why there's a ribbon renderer? You can put those validation rules. You can, there's some predefined ones, but you can add them as you want as well. And that's it. Thank you. Oh. So, any questions?
I have one question. I'd like to ask about the people inside the city. Since you emit the people, like a crowd or something, of process, and did you use the staple meshes or the models with the vertex animation?
Well, we have the vertex animation textures from Houdini, of course, but there's a lot of people spawning at once, yeah? And basically, the distance from a player is really, really big, and we decided that at the most, like the closest zoom possible, we're spawning meshes, but at some given distance, it changed to sprite. And it's just the like silhouette of a dude that's hanging around the city. We're spawning them from those emission points, but we're spawning them from camera as well. So if a player goes further to the ground, the more are spawned, and some predefined location as well.
Hey, do you have from other departments like design and restrictions in case of optimization system? It's any particular system should be in a high quality besides besides lowering the quality of entire?
Basically not. Like we as VFX artists decide what's more important, what's not. There are some VFXs, of course, that should be visible at every quality level because they're like information for a player. It can be something UI-ish or something like that. But basically, we decide as VFX artists what should be in better quality and what we dump, basically, from a project. So, any more questions?
From the curiosity, what techniques do you use while making flipbook animations, like photo bashing or something, or is it everything hand drawn?
It kind of depends on what project are you making. Like Frostpunk 2 have really realistic smokes, and so I just go to inside the Houdini and render them there. As well, you can render the motion vectors there, so it's really everything in one place. But when I was making like shooter FPS and it was really stylized, then I used Embergen, I rendered some flipbooks, and on top of it, I just draw something from hand. But I'm not a fan of driving by hand. I'm not as good as some of you are.
Okay.
One more question. What would be your tips for beginner VFX artist?
My tip is to remember to always know your place in project, in your line. Like, I know that VFX for you is like really important for you to be played at as good quality as it can be. I want to spawn a lot of particles at once, but remember that you're like the bassist in a rock band, you know? Like, when there's a VFX missing, everyone will notice. But if the VFXs are really good, no one will even think about them. So if they're placed good in a project, they don't scream at the player, oh, okay, it's me, it's fancy explosion, then, yeah, like, know your place in a project, and remember that it's, that the whole project, the whole game is connected, like, there's a lot of people working at this game, and everyone wants to show their skills, basically. Yeah, it's fine, yeah? I'm a bassist player as well, so.
Okay, if there's not more questions, yes, give Paweł one more applause.
Thank you so much.